Welcome and Jai Hind everyone. Today we shall start class 10th uh, chemistry NCERT exemplar questions. NCERT exemplar book. Question solution. And the first question of the NCERT exemplar book is, which of the following is not a physical change? A. Boiling of water. To give water vapor. Second option is melting of ice to give water. C is the dissolution of salt in water, and D is the combustion of LPG, liquefied petroleum gas. So among these options, which one is not the physical change, you will have to be select, or we will have to be select. So student, to solve this question of NCERT exemplar book, you must have to know about the physical change and the chemical change. And physical change is a kind of change in which no new substances or compounds will be formed, and the process will be reversible. So to solve this, the hint point will be um, uh, physical change. If you are saying, so physical change, no new compounds, or you can say substance, will be formed, and the process is reversible process. Reversible meaning is that whatever the changes is taking place, uh, from that change you can restore the initial state of the substance. Means you can reverse the process. If we if anything is going from stage 1 to 2, and if you are able to convert the state 2 to the state 1, so that will be a kind of reversible process and it will be a physical change. So if the process is reversible and no new compounds or substance will be formed, so that will be a kind of physical change. And suppose we are talking about the chemical change. So chemical change, in this new compounds will be formed, and process will be process will be irreversible. Means you cannot get the initial stage of the system, you can say. So if you are able to restore the starting position of any substance, so and there is no formation of any new compounds or substance, so that kind of change will be a physical change. But if there is the formation of new compounds and you are not able to reverse that process, so that will be a kind of chemical change. So boiling of water to give water vapor. So here you are looking that water you are boiling and you are getting the water vapor. So there is no any formation of new compound, and from the water vapor, suppose you are boiling water, and whatever the water vapor is coming out, if you are um, placing a kind of plate here, or you can say obstacle, so this vapor will get convert into water itself. Or the other way, if you are decreasing, if you are cooling this vapor by cooling water vapor, we can again get water. So here you are looking, there is no any formation of new compound and the process is reversible. By cooling the water vapor, we can again get the water, so we can get the initial stage. So it is a kind of physical change. And melting of ice to give water, of course here you are melting ice into water. So ice and water both are uh, the same compound, which is H2O. Whether it is ice and or water, it is nothing but your H2O only, the same compound. And by the help of water you can again get the ice. If you are freezing water, so you will get ice, so you can reverse the process and there is no any formation of new compound, so it will be also kind of physical change. Here you are looking the dissolution of salt into water. So it will be a kind of physical change, because if you are adding some salt in water, here is the water, here is the salt, by the help of crystallization you can again get the salt which was dissolved in that water. So what is in the crystallization process? Here the evaporation of water takes place. Here the evaporation of water takes place, and when all the water gets evaporated, ultimately at the end you will get the salt which you had dissolved in it. So here you are looking that you can restore the initial stage in this dissolution of salt in water. Similarly, as we do in the case of sea water, we evaporates water and gets back that salt which was dissolved in that sea water. So it is the kind of a physical change as we are able to restore the initial stage. Now you the next option is the combustion of LPG, and here you are looking when you will combust anything, when you will burn anything, so it will get react with oxygen, and you will get carbon dioxide and water as a product. So what is the product of a combustion reaction? Product of a combustion reaction is nothing but the uh, uh, carbon dioxide and water. 1 minute, just wait 1 minute. LPG generally you will know that it will be a propane or butane. It is a kind of hydrocarbon which is a mixture of butane and propane. So suppose we are uh, uh, taking this combustion of this butane, C4H10. It is a combination of butane plus propane, C3H8, and C4H10. It is your butane and it is your propane. So the next option is saying to you that if you are doing combustion of LPG, which is nothing but the, you can say, combustion of propane or butane. So here suppose we are considering this propane, C3H8, and its reaction with oxygen. Combustion is nothing but the burning in the presence of oxygen. So you will get carbon dioxide plus water as a product. Always you will remember this. Here is 3 carbon, so it will become 3 CO2, and H is 8 here, yes, 2 4 H2O. Okay, now 4 oxygen plus 6 plus 3 to just 6, and this 4, 10 oxygen, I think 6 5 6 plus 4 5, yes, 5 O2. Okay, so in this way you can uh, come to know that here there is a formation of new compound which is carbon dioxide and the water, and with the help of this reaction, this combustion reaction is not a reversible reaction, it is a irreversible. It is irreversible, and these are the new compounds, these are the new compounds you are getting. And similarly, suppose you are saying C for the this C4H10, and if it's reaction with oxygen, obviously as a product you will get carbon dioxide and water as a new product. Here is 4 CO2 and 5 H2O, 4 CO2 and 5 H2O, and 8 oxygen plus 5 oxygen, 13. 13 oxygen. So here what can you do? 13 by 2, 13 by 2, so it will give you 2C4H10 plus 13O2, 8CO2 plus 10H2O. Nothing you are doing, you are just multiplying it. Here is the 13, here is 13 H2O, here is 13. So 13 by 2, as here was that 8 plus 13 oxygen, here was 2 oxygen. So this 13 2s are 26, 26 divided by 2 will give you 13. So when you will multiply it by 2, so you will get 2C4H10 this now, and here there is a formation of new compound along with this reaction is irreversible. So it will be a kind of chemical change and it will be your answer. Now the second question. I will write the question, students. If you don't want to read the question, you can skip this part. So the second question is saying the following reaction is an example of first is your displacement reaction, second is your combination reaction, third is your redox reaction, and the fourth one is saying neutralization reaction. And the reaction is 4NH3 ammonia in gaseous state plus 5O2 oxygen in gaseous state is giving you nitrogen monoxide, 4 molecules of nitrogen monoxide plus 6 H2O in the gaseous state. So this question is saying to you that here is the reaction, and in this reaction which reaction is taking place. So in this reaction, if you will carefully look, so you will find that here from NH3 to NO, there is a addition of oxygen, and addition of oxidation is nothing but your oxidation. And from O2 to H2O, if you look, here is the addition of hydrogen. And addition of hydrogen is nothing but the reduction. So in the same reaction, if in the same reaction both oxidation and reduction is taking place, so that kind of reaction is called as redox reaction. So in this I had forgotten to write the options. So your options: A is your first and fourth, B was your second and third, C was your first and third, and D was your third and fourth. So one thing we have come to know, that the reaction, the given reaction in this both oxidation and reduction is taking place, so it will be a kind of redox reaction. Whether it is a combination reaction? No. Combination reaction will be something like it: A plus B will give you single compound. So if you are getting single product, so that will be a combination reaction. But here you are getting two products, so it will be not a kind of combination reaction. Displacement reaction, we'll see that whether it is a displacement reaction or not. So here in this question, students, you will remember that displacement reaction not only takes place in the case of metals, but it also happens in the case of non-metals. And very carefully, if you look at to this question, so you will find here oxygen is replacing this hydrogen. In place of hydrogen, the oxygen is going, and you are getting this NO. Here is the oxygen is replacing this hydrogen, so it will be a kind of displacement reaction also. And neutralization reaction, look student, in the case of neutralization reaction, your product will be salt plus water. Salt plus water. So we are getting water, but we are not getting any kind of a salt here. Here is the gas we are getting. No any kind of salt formation is taking place here. So it will be not a kind of neutralization reaction, as in the case of neutralization reaction we will get salt plus water as a product, which will you study in the in chapter acid, bases and salts. So this neutralization reaction is also wrong, and which one is correct? First and third. So the first third is your C option. So C option is correct. So here in this question, student, you are finding that the addition of oxygen is the oxidation, and the addition of hydrogen is the reduction. So from the next question you will come to know what is that oxidation and reduction in better way. So let us come to the third question first. Uh, and the third question is telling that which of the following statement about the given reactions are correct. And the reaction is 3Fe solid, 4H2O gaseous state is giving you Fe3O4 in solid state plus 4H2 in gaseous state. And the first is first statement is that iron metal is getting oxidized, and the second statement is water is getting reduced. Third is water is acting as reducing agent, and the fourth one statement is telling that water is acting as your oxidizing agent. So student, to solve such kind of problem, uh, we will have to be know about what is oxidation and what is reduction. So oxidation, student, you will remember, is the addition of oxygen, or if there is a removal of hydrogen, and reduction, as the addition of oxygen is oxidation, in the same way, not in the same way, in the opposite way, you can say removal of oxygen is your reduction, and addition of hydrogen is your reduction. So oxidation, addition of oxygen, removal of hydrogen. Reduction, removal of oxygen or addition of hydrogen. Along with this, student, uh, you will remember that oil means oxidation is loss of electron. Means in if somewhere there is a loss of electrons, so at that place, uh, oxidation will take place. So oxidation is also the loss of electron. And you can remember oil. Oil means oxidation is loss of electron. So when there will be the loss of electron, so its oxidation number will get increased. Oxidation number increases. So if the oxidation number is increasing somewhere, so there will be the oxidation. So along with knowing addition of oxygen and the removal of hydrogen is oxidation, you will also remember that oxidation is the loss of electron, and here in this case the oxidation number will get increase. And in the same way you will remember that for rig reduction is gain of electron. So if somewhere there is a gain of electron, so there will be the reduction. There will be the reduction. And if there is a gain of electrons, so oxidation number will get decrease. Here, if you are finding that oxidation number is getting decreased, so there will be the reduction. I will try to solve this problem in two ways. First way will be the simpler way, in which we will know the things by the help of addition of oxygen or removal of hydrogen. So here in this you are finding that there is a 3Fe it is the reaction given to us. So here you are finding the addition of oxygen is taking place. So the addition of oxidation is taking place, meaning is that addition of oxygen is what? Here oxidation is going on, and here you are finding from H2O to H2 there is a removal of oxygen. And what is removal of oxygen, student? Here the reduction is taking place. So once again this 3Fe in solid state plus 4H2O in gaseous state is giving to you Fe3O4 in solid state plus 4H2 in gaseous state. Here is the addition of oxygen. So addition of oxygen is oxidation. So Fe is getting oxidized, and here from 4H2O to 4H2 there is a removal of oxygen, and the removal of oxygen is your reduction. So we have come to know about this by the help of the hint which I had provided to you, what will be called as your oxidation and what will be called as your reduction. One more thing you will remember in this kind of question, student, that the substance which gets oxidized acts as a reducing agent. So whatever the substance uh, will get oxidized, that will act as your reducing agent, and the substance which gets reduced acts as a oxidizing agent. So here, since the oxidation is taking place, so Fe is getting oxidized. So since it is getting oxidized, so it will act as a reducing agent. And here the reduction is taking place, reduction of water is taking place, so it will act as your oxidizing agent. So you will remember the substance which is getting oxidized, that will act as your reducing agent. You will add one T here. There is the pointer here. Yes. Reducing agent, and the substance which is getting reduced, that will act as your oxidizing agent. So here you are looking that Fe is getting oxidized. So it will act as your reducing agent. And here the water is getting reduced, so it will act as your oxidizing agent. So now come to these statements given to us. So you are finding that iron metal is getting oxidized. Yes, you are looking in iron there is a addition of oxygen, so here is the oxidation is taking place. So the first option is correct. And water is getting reduced. Yes, you are looking that water is getting reduced, so it is also correct. Water is acting as a reducing agent. No, student, here you are looking that since water is getting reduced, so it will act as a oxidizing agent. So this statement is wrong. Water is acting as an oxidizing agent. Yes, water is getting reduced, so it will act as your oxidizing agent. So yes. And in the option, I had forgotten to write the options. So the options were, first was that your first, second and third. Second was that your third and fourth. And third one was your first, second and fourth. And D option was second and fourth. So you are finding first, second and fourth is correct, and that is given in the option number C. So it was the one way of solving such kind of problem, in which you will see that where the addition of oxygen or removal of hydrogen is taking place, or there is a removal of oxidation, or removal of oxygen or addition of hydrogen based, by the help of that you will first find out that where the oxidation is taking place and where is the reduction is taking place. Now once you have come to know which is getting oxidized and which is getting reduced, then you will say that the substance which is getting oxidized is acts as a reducing agent, and the substance which is getting reduced act as your oxidizing agent. Now alternate way of solving this problem is go for the oxidation number. So you are finding that reaction 3Fe plus 4H2O plus, not plus, Fe3O4 plus 4H2 is the reaction given to us. And you are finding that oxidation state of this iron, nothing is combined with this iron, so oxidation state will be 0. Hydrogen, nothing is combined with this, so oxidation state will be 0. Here if you will find, if you will see that oxygen, you Fe3O4, so you know that oxidation number of oxygen is -2, as it is required 2 electrons to complete its octet. So -2. So and the oxidation state of iron you want to know, as here is the 0, what will be the oxidation state of this iron here, that we want to know. So what can we do? Here is 3, so you will write 3x, and this 4 is here, so 4 into 2, 8, and with minus sign means -8 is equals, must be equals to 0. So x will come out 8 by 3, which is 3 2 is 6.67 something. So here you are looking that your oxidation number is increasing. Oxidation number of iron is increasing, and if the oxidation number of any substance is increasing here, so there will be the oxidation. So here you are looking that oxidation number is increasing, so here will be the oxidation, and it will act as your reducing agent. And here you are looking that for H2O, you have come to know that the oxidation number of this oxygen will be -2, and we want to find out, here is oxidation state of this H2 is 0, so we want to find out what will be the oxidation number of hydrogen here in this water. So here is -2, and hydrogen we don't know, so we'll write x. This 2 is here, so 2x, and oxygen is 1, so 1 into 2 is 2, with minus sign, -2 must be equals to 0, so x will come out 1. So here you are looking that here the oxidation number is decreasing, and as the oxidation number is decreasing, so here the reduction is taking place, and as the reduction is taking place here, so it will act as your oxidizing agent. So here you are looking that iron is getting oxidized and acting as your reducing agent, and water is getting reduced and acting as your oxidizing agent. So based on this information, you will find that in this given question, the first, second, and third, fourth option is correct. The third option, which is saying that water is acting as a reducing agent, is wrong in it. So it was the other way of solving this kind of problem, and you must have a better command on ninth class to know about this oxidation number. And if you are finding it hard, you can go for this way, first way, in which by the help of addition of oxygen and removal of hydrogen, you will get the same answer. So students, you are looking that in this third question, when were we solving this from the oxidation number way. So here you are looking that since here the hydrogen had the oxidation number 0, so we were interested in the oxidation number of hydrogen in this compound. So uh, by our awareness, we had said that the oxidation number of oxygen will be minus 2, so oxidation state of hydrogen will come 1 here. Similarly, since here the oxidation number of iron was 0 here, so we were interested in the oxidation number of iron present in this compound. And based on our awareness, we had said that since the oxygen have the requirement of uh, uh, has the requirement of 2 electrons to complete its octet, so its oxidation number will be minus 2. And we had done the some calculation to find out the oxidation state of iron. So we will find out the oxidation state of that element in which we are interested. So you will remember this. So to have a better grip on this oxidation and reduction topic, one more problem I am giving you from my side, and it is not present in your NCERT exemplar book. And the question is, you can say it is a practice problem. Consider the reaction and here twice HBr reacting with this Cl2 is giving you twice HCl plus Br2. And question is saying to identify the substance first getting reduced, second getting oxidized, third acting as a oxidizing agent, and the fourth one is acting as a reducing agent. So it is the problem from my side, and we'll come to the solution of this problem. So here in the reaction you are looking, here is twice HBr reacting with Cl2, giving you twice HCl plus Br2. So first we will go from the simple way. So here if you will carefully look, here is the removal of hydrogen. So since here is a removal of hydrogen, so here oxidation will take place. And since here the oxidation will take place, so it will act as your reducing agent. Obviously, which will get oxidized and which will act as a reducing agent, that will be present at the reactant side. And at the reactant side you are finding HBr. So HBr is getting oxidized and it is acting as a reducing agent. So here you are looking that which is getting oxidized, HBr is getting oxidized and it is act as a reducing agent. And here if you will carefully look, this Cl2 to twice HCl, here the addition of hydrogen is taking place. So addition of hydrogen is what? Reduction only. And which will get reduce this substance which is present at the reactant side, that is Cl2. So where the substance which is getting reduced is your Cl2, and since here the reduction is taking place, so it will act as your oxidizing agent. So which is acting as your oxidizing agent? Cl2 is acting as your oxidizing agent. So it was very simple to follow the first way. We will try it by the help of the oxidation number way. So the reaction is twice HBr reacting with Cl2 is giving to you uh, twice HCl plus Br2. So here you will remember, student, first uh, this Cl2 is combining with no one, combined with no one, so its oxidation state will be 0. Br2 oxidation number will be 0, as it has not combined with anyone. Here if you are looking to this HBr, we will be interested to find out the oxidation number of this Br, oxidation state of this Br. So H oxidation number of hydrogen will be +1. So +1 plus X is equals to 0 means X is equals to -1 means Br will have -1 oxidation state here. Similarly, hydrogen will be the +1 oxidation number, and we are interested to find out the oxidation number of Cl, as we are aware about the oxidation number of Cl2 here is as your 0. So we will be interested to find out the oxidation number of this Cl, so it will be suppose X. So +1 plus X should be equals to 0, so X will come out -1. So here also you are looking the oxidation number of Cl is your -1. So in when are you following the oxidation number way, you must have to aware about that element in which you are interested to find out the oxidation number. So you will notice this point always. So here you are looking this -1, the oxidation number of Br is going from -1 to 0 here. -1 to 0 means oxidation number is increasing. Oxidation number is increasing by the loss of one electron. So no, I'm sorry, oxidation number is increasing. Yes, oxidation number is increasing by the loss of one electron. So here the oxidation number is increasing, -1 to 0, it will get increased. So if it is increasing, so it will get oxidized. If oxidation number is increasing, so it will get oxidized. So which will get oxidized? The compound which is present at the reactant side. So HBr will get oxidized, and since it is getting oxidized, so it is acting as your reducing agent. And here you are looking chlorine have the oxidation number 0 at the reactant side, but at the product side it is it have the oxidation number -1. So it is the oxidation number is decreasing here by the gain of one electron. So here the oxidation number is decreasing, and since oxidation number is decreasing, so it will get reduced here. So here what will happen? Here the reduction will take place, and since it is getting reduced, so it will act as your oxidizing agent. So here you are looking, student, that HBr is getting oxidized and it is acting as your reducing agent, and Cl2 is getting reduced and acting as your oxidizing agent. So the same answer we are getting here. Cl2 is your oxidizing agent and it is getting reduced, and HBr is your reducing agent getting oxidized. Now come to the fourth question of the given book, and the fourth question is saying which of the following are exothermic processes. Statement first is reaction of water with quicklime. Second statement is dilution of an acid. Third, evaporation of water. And the fourth one is sublimation of camphor. Sublimation of camphor. And the options are first and second. B is second and third. C is your first and fourth. D is your third and fourth. So student, to solve such kind of problem, first we shall know what is an exothermic or endothermic processes. So you will remember exothermic reactions exothermic reactions release heat into the surrounding. So any reaction which is releasing heat into the surroundings will be called as your exothermic reaction, while endothermic reactions endothermic reactions absorbs heat from the surrounding, absorb heat from the surrounding. So any reaction which is giving out heat to the surrounding will be your exothermic reaction, will be your exothermic reaction. and any reaction which is taking heat from the surrounding. If it is taking heat from the surrounding, so it will be your endothermic reaction. So if it is giving heat to the surrounding, so it will be your exothermic reaction, and if it is absorbing heat from the surrounding, so it will be your endothermic reaction. So the first statement is saying the reaction of quicklime with water. Reaction of quicklime with water. So we know that first, when quicklime will react with water, it will form calcium hydroxide, and in this kind of reaction there will be large amount of heat will evolve. So it is a reaction in which uh, the heat is given to the surrounding, so it will be a kind of exothermic reaction. As we had seen that whenever we adding quicklime in water, quicklime in water, so after some time whenever we touching the container, so we were feeling hot. So it is indicating that in this reaction heat is evolved or heat is given to the surrounding, as by touching the container we can say that since it is a hot, so the heat is evolved in this case. The meaning is that it will be a kind of exothermic reaction. Second question is saying dilution of acid. Always you will remember that dilution of an acid is exothermic reaction. So dilution of any acid is exothermic reaction, meaning is that heat will go to the surrounding or heat will release to the surrounding. Obviously you will add drops of acid into the water, not water in to the acid. Always you will remember. Third is the evaporation of water. So student, you will be aware that in class 9th it was written that evaporation is a surface phenomena and it gives cooling effect. So evaporation gives cooling effect. When does it give the cooling effect? When it will take heat from the surrounding. When it will take heat from the surrounding, then only it can give the cooling effect. So since evaporation gives cooling effect, so obviously it will take heat from the body or the system. So evaporation, always you will remember, wherever the evaporation is taking place, evaporation is endothermic reaction. Endothermic reaction, as it will take heat from the body or the surrounding to change its state from liquid to gas. And the fourth one is your sublimation of camphor. So obviously solid will get converted into the gas without converting into the liquid in the case of sublimation. So in this case we gives heat. Now we heat the solid to convert it into the gas. So as we are giving heat, so we are giving heat, so meaning is that we are taking heat from the surrounding. Surrounding is providing heat to the solid to convert into the gas. So since here the heat is taken from the surrounding, that's why it will be a kind of endothermic reaction. So our this first option, reduction of water with reaction of water with quicklime, obviously CaO when combined with water will give you calcium hydroxide plus heat. So since heat is going to the surrounding, so it will be a kind of exothermic reaction. And you will remember that dilution of an acid is your exothermic process. Evaporation, since evaporation gives the cooling effect, and when it will give the cooling effect, obviously when it will take heat from the surrounding or from the body, then only it will get evaporate. So evaporation gives cooling effect, meaning is that it will take heat from the surrounding. It is not a exothermic process, it is endothermic process, so it's wrong. Sublimation of camphor, since to convert solid into gas we are providing heat to the solid, so since heat is taken from the surrounding, so sublimation of camphor will be endothermic process, and this first and second is the and exothermic process. So option A is the right answer of this question. Now come to the fifth problem of the given book, and the problem is three beakers labeled A, B and C labeled as A, B and C, each containing 25 ml of water. Small amount of NaOH, sodium hydroxide, anhydrous copper sulfate, meaning is that there is no water molecules present in that, and NaCl, sodium chloride, were added to the beaker. Beakers A, B and C respectively. It was observed that there was an increase in the temperature of solution of the solution contained in beaker A and B, whereas in case of beaker C, the temperature of the solution falls. Of the solution falls. Which of the following statement or statements is or are correct? First statement is in beaker A and B, exothermic process has occurred. Second statement, in beaker A and B, endothermic process has occurred. Third one, in beaker C, endothermic process has occurred. First write exothermic. Exothermic process has occurred. And the fourth one, in beaker C, exothermic process has occurred. So very easy solution. Here the question is big, but the solution will be so small if you know the concept. So here we have three containers, A, B and C, and in this we are adding NaOH. Here we are adding anhydrous copper sulfate. Here we are adding NaCl, and we are finding the temperature of solution A gets increased and the temperature of solution B container also gets increased, but the temperature of solution present in beaker C gets decreased. So these information has given to us, and where is the exothermic process and where is the endothermic process, we have to find out. So since here the temperature is increasing of the solution A and B, so as the temperature is increasing, meaning is that heat is released. Heat is released. It is released. Then only the temperature of the solution will get increased. When the heat will be released and the temperature of solution B is increasing, meaning is that heat is released in this case. But the temperature of solution C is getting decreased. The temperature of solution C is getting decreased, meaning is that here heat is absorbed. So here the temperature is increasing, meaning is that in the reaction heat is releasing out. But here the temperature of solution C is decreasing, meaning is that here the heat is being absorbed, and wherever the heat is released, that will be a kind of exothermic reaction, you all know. So heat is released, so it will be your exothermic. Heat is released, it will be your exothermic. But heat is absorbed and temperature is decreasing, meaning is that wherever there is absorption of heat, there will be your endothermic process. So I had forgotten to write the options of it. So first write the options. A option is your first, and I'm sorry, not first, first only. B is your second only. C is your first and fourth, D is your second and fourth. So the statement first is saying that in beaker A and B exothermic process has occurred. Yes, when the exothermic process will occur, then only the temperature of the solution will get rise. So in the beaker A and B exothermic process has occurred, it's true. But the second statement in the beaker A and B endothermic process has occurred, it's wrong. In this, exothermic process has occurred. In C, you are looking that endothermic process has occurred. So in beaker C exothermic process has occurred is wrong, but this in beaker C exothermic process has occurred. Oh, okay, I'm sorry, here should be endothermic. My mistake. Okay, here in this there should be endo. Yes, so this is statement in the beaker C endothermic process has occurred. It's correct. So you are finding first and fourth is correct. So option C will be your correct answer. Thank you all of you. Other problems we will solve in the next part.